Student, welcome to Math Ninja Academy, and in this session we're going to look into a new method of differentiation, which in this case is called the chain rule. Before we dive deep into the chain rule, let's quickly do a recap of what we have studied previously. Previously, we have looked into what we call the product rule. The product rule, let's say maybe you're given y, which is equal to f of x, which is being multiplied by g of x. Both f of x and g of x are functions of one variable. To differentiate this, you're going to say y prime, which is equal to, you're going to differentiate the first function f prime of x, and then you keep the second function g of x plus, and then you differentiate the second function g prime of x, and then you keep the first function. We called this the product rule. Where do we use the product rule? We use the product rule when we have product of two or more function, 2 or 3 function. Hence, you see here we have f of x, which is being multiplied by g of x. So today we are going to explore a new rule, which is called the chain rule. Suppose you're having your function, which is y is equal to f into g of x. Where do we use the chain rule? We use the chain rule whenever we have a composite function. We have a composite. We have an outer function, which is g. This is the outer function. Outer function, and then this g here is the inner function. So we use chain rule whenever we are having a composite function. That basically means that we use the chain rule when we have an outer function and an inner function. So that's where we use the chain rule. So how are we going to solve using the chain rule? Well, suppose you're given y is equal to f into g of x. The derivative of this, which is represented by dy over the x, is going to be, you're going to take the derivative of the outer function, which is f prime, and then you keep the inside function, which is g of x. Then you multiply by the inner function, the derivative of the inner function, which is g prime of x. Let's look at an example. It will make sense. So I'm just gonna quickly re-explain the chain rule. So the chain rule basically means that you are dealing with a composite function and you are required to determine the derivative of this composite function. Like I said, composite function is when you have the outer function and an inner function. You basically have a function inside another function. So you apply chain rule whenever you have the composite function, and the method is this one. If you are required to take the derivative, it's going to be the y over the x, which is equal to, you take the derivative of the outer function and then you keep the inner function, and then you multiply by the derivative of the inner function. So let's say maybe you're given the problem, I'm just going to call it 1, y is equal to sine of x squared plus 2, and you're required to take the derivative of this. Let's say maybe they say take the derivative, determine the derivative. So first thing first, you need to identify your f and your g. So the outer function is what? Is sine, is going to be our f, and the inner function is this guys here, x squared plus 2 will represent our g. So how are we going to solve this? Let's take the derivative now. What is the derivative of y? It's going to be the y over the x, or y prime, is equal to, what does the rule says? The rule says you take the derivative of the outer function, which is f prime here. We have our f as what? As sine. So the derivative of sine is going to be what? It's going to be cos. Then you keep the inside function, which is g. The inside function is g, which is what? X squared plus 2. And then you multiply it by what? The derivative of the outside function, which is what? The derivative of g. And we have our g as what? As x squared plus 2 plus 2. So derivative of x squared plus 2 is going to be 2x. And then if we simplify this, we're going to end up with 2x cos of x squared plus 2. This is how we solve using the chain rule. However, there are some problems that actually combines the chain rule and the power rule. They combine the chain rule plus the power rule. So let's look at maybe an example on how to solve such problems. So in general, let's say maybe you have your function which is y is equals to what can I say, f of g of x, which is raised to the exponent n. The derivative dy over the x is going to be what? It's going to be, you take the derivative. This n actually represent the exponent. And this whole composite function f of g of x is raised to the exponent n. So to take the derivative of such function, you're going to consider the power rule and the chain rule. So first thing first, you're going to take the derivative using the power rule. So you're going to have n, you take the n, you multiply the whole function, and then you keep the inside function, which is f of g of x. You keep the whole inside function, and then from the exponent you subtract 1, and then you multiply by the derivative of the inside function, which is going to be what? F prime of g of x multiplied by g prime of x. This is how you solve. So let's look at an example. I'm trying to save time. Example 1. What can I say? Okay, let's say maybe we have y, which is equals to sine of, what can I say, x, which is raised to the exponent 5. Ne? The y over the x is going to be what? You take the power rule, so it's going to be 5. You keep the inside function, sine of x, which is raised to the exponent 5 minus 1. Remember, from the exponent you subtract 1, multiply by the derivative of the inside function. The sign is going to become the cos of x, which gives us 5 cos x multiplied by the sine of x, which is raised to the exponent 4. And then this is the final answer. Let's look at the second example. Example 2. Let's say maybe you have y, which is equals to what can I say, the ln of 5x squared plus 10, which is raised to the exponent 3, and you are required to take the derivative of this. Derivative of y is going to be the y over the x, which is equals to this exponent. Basically means that we are going to apply chain rule plus the power rule. So we're going to say 3, you keep the inside function, ln of 5x squared plus 10 to the exponent. From that exponent we subtract 1, which becomes 2. You multiply by the derivative of the inside function d over the x of ln of 5x squared plus 10. Ne? So your answer is going to be 3 into the ln of 5x squared plus 10 squared multiplied by the derivative of ln is going to be 10x all over 5x squared plus 10, which basically gonna end up giving us 3 multiplied by 10x is going to be what? It's going to be 30x, and then ln of 5x squared plus 10 close squared all over 5 squared plus 10, and then this is the final answer. And then for a challenge problem based on this rule, you can attempt this problem. So you are required to determine the derivative. Ne? Determine the derivative if you are given your function, which is f of x, which is equals to e to the exponent sine of x squared. You see we have a composite function here, which is raised to the exponent what can I say, 4. Please attempt this problem, And then this is gonna be the end of the session. For more content, please don't forget to subscribe, like, and